So guys, today we will start with a new topic about uniform flow in channel. Just to give you a hint what we covered last meeting because it's very important. If you have a channel with water depth, so we can figure out area, and you already have discharge, so we can figure out velocity. If the water depth varies, lower water depths, so we have different area, we have the same discharge, so we have different velocity. If you have another depth, so we have another area and another velocity. You can, in each situation, figure out what is the value of E, specific energy, equal depth, plus V square divide 2G. We have here depth and velocity. We have a different depth and different velocity. We have different depth and different velocity. So we have E1, E2, E3, E4 for different cases. If you can set up a relationship between the energy, the specific energy, and the water depth in the channel, your relationship looks like this. From this curve, this point can give you the minimum value for E. At the minimum specific energy, we can expect at this case D critical, which is called critical depth. Okay? This critical depth is very important because if here is the critical depth, D critical, if the water depth in the channel greater than the critical depth, that means your flow will be subcritical flow. If the depth in the channel is smaller than critical depth, that means it will be supercritical flow. If you have a transition from supercritical to subcritical, you have to expect something here called hydraulic jump. We have a different technique to figure out this phenomenon by using something called Froude number. This number can give you indication what is the type of flow. If this number is smaller than 1, it will be subcritical. If this number greater than 1, it will be supercritical. If this number equal 1, it will be critical. Also, this number can give you indication what is the type of flow. And last week, we learned how to determine the Froude number. Last week, we learned how to determine the critical depth. Today, we have a different topic, a little bit. If you go outside right now, in front of your house, on your city, in your town, and you have a canal or channel, and you can, with any way, measure the dimensions of this cross section, and you can figure out the water depth. Believe me, today I can tell you, you can calculate the velocity. Sure? Without anything, without any other thing? No. Just tell me what is the cross-section dimension, what is the water depth, what is the slope of this channel. I can tell you what is the velocity. And I can tell you what is the discharge. We have equation here for velocity, probably the same equation for discharge, but a little difference. For someone called Manning. Manning or Robert Manning is an engineer, presented an equation to compute the velocity and subsequently the discharge in a channel. And this equation is common, widely used in United States. Velocity equal K divide N time RH to power 2/3 S to power 1/2. K is a factor, constant. We have two values, 1.486 if you are using US unit, or 1 if you are using SI unit. For example, if your dimensions in feet and your discharge cubic feet per second, and the velocity will be feet per second, that means you are using US unit. So K equal 1.486. If you are using meter, cubic meter per second, that means you are using SI unit. So K equal 1. Does that make sense? So this value of K is a constant. How much? Based on what is or what are the units you are using. US unit, this value 1.486. If you are using SI unit, be careful, equal 1. N called Manning coefficient will be given. Manning coefficient is empirical number that describes the roughness of the channel lining. That means if you have a channel made from concrete, different than made from clay, different than channel made from plastic, channel made from stones, all of these channels will be different based on the Manning coefficient. So it will be given. RH, do you remember this term? Guys, do you remember RH? This term is very important. Hydraulic radius. Do you remember how can we do, we calculate it? Equal the area of the flow divide weighted perimeter. So this term, hydraulic radius to power 2/3, RH is hydraulic radius equal area divide P. Area is the cross-section area of flow. P is the weighted perimeter. The last term is slope of the channel. If you draw longitudinal profile or longitudinal cross-section of the channel, we have difference in elevation. So if you divide the difference in elevation H with the difference in length, horizontal length L, you can get a slope. Okay, and we covered this last meeting, I think. So this term or these terms for velocity, if you multiply it by area, you can get Q, because all of us know Q equal area times V. So V alone equal K divide N, R to power 2/3, S to power 1/2. So if you multiply this V by area, you can get the discharge. Okay? Any question so far? Any question? We have few points here. Manning coefficient is empirical number. It looks like the friction factor that we covered before. All values will be given, don't worry, based on the material of lining. Hydraulic radius, this is I covered last meeting. Hydraulic radius is a measure of the hydraulic efficiency of a channel. The greater value of hydraulic radius, the more discharge is conveyed by the channel, which is more efficient. So wide, shallow channel has relatively large wetted perimeter compared to cross-section area and therefore less efficient than. So the final conclusion, if the hydraulic radius is bigger, the channel will be more efficient. Let's see this example. We have two channels. The first one has this cross-section, width 10, depth 2. Another one with width 5, depth 4. My question is, which channel will be more efficient? Or which channel will carry more flow? What do you think? I cannot decide because the area here is 20. The area here is 4 times 5 is 20. So the same area. So how can I figure out the difference? Which one is more efficient? Which one will carry more flow? We can do this comparison based on the hydraulic radius. Equal area divide P. The area here equal 20. What is the value of wetted perimeter? This wetted perimeter, what is the value? 2 plus 10 plus 2 is 14. Area here is 20. What is the value of wetted perimeter? 4 plus 5 plus 4, 13. So hydraulic radius for channel number 1 equal 20 divide 14. Hydraulic radius for channel number 2 equal 20 divide 13. So 20 divide 14 equal 1.428. 20 divide 13, 1.538. The more value for hydraulic radius, the more efficient. So this one will be more efficient. This one will carry more flow. This one will be better than this one. Any question? Looks good. Find the quantity of flow. What is the value of discharge? If we have concrete rectangular channel, concrete, made from concrete, here is the channel. With Manning coefficient, because it's from concrete, equal 0.013. Having a width, this channel has a width equal to 12 feet. And the slope equal 0.02 feet per feet. And the normal depth, the depth of water inside this channel, 1.58. Can you tell me what is the value of this discharge? I can tell you using Manning equation. One of you will say, hey, we can say this discharge equal area times V. We understand the value of area equal this width times this depth. Yeah, good work. What is the velocity? The problem did not give you any information about velocity. We have only the dimension of the cross section and the slope of the channel, nothing else. So the only way to figure out discharge is using Manning equation. Q equal K divide N, area, hydraulic radius to power 2/3, slope to power 1/2. If you go back, you will say, hey, we have two equations. I'm gonna use this one because I'm looking for discharge. If you are looking for velocity, go ahead and use this one. The only difference, this one has area, this one does not has area, but everything is the same. Let's start. What is the value of K? What is the value of K? Do you think the value of K will be 1 or 1.4868? 1.4868 because your unit is US unit. The value of Manning coefficient 0.013. What is the area? The area of flow 12 times 1.58. 12 times 1.58 will be 18.96. What is the value of the hydraulic radius? The value of hydraulic radius equal area divide perimeter. Let's do what is the value of perimeter. This length plus this one plus this one. Equal 15.16. So the hydraulic radius will be area 18.96 divided weighted perimeter. This value will be 1.25. So the hydraulic radius is 1.25 to power 2/3. What is the slope of this channel? 0.02 to power 1/2. Okay. So guys, we can calculate the final discharge value. 2/3 times 0.02 to power 1/2 times 18.96 times 1.468 divide 0.013 equal 351.5 cubic feet per second. So you can calculate the discharge for any channel around your house if you know what is the cross-section dimension, what is the water depth, what is the material of this channel. Probably most of the channels around us here made from clay, or sometimes it's lining with concrete, sometimes. So based on the material of lining, we can figure out this one. We have a table. And also you need to figure out what is the slope. Probably on this Thursday in the surveying class, I will teach you how to calculate the slope for any ground by using leveling. Okay, once you have all of this information, we can use Manning equation to figure out the discharge or figure out the velocity. Any question, guys? Any questions so far? One more example. One more example. What is the normal depth? Wow, the normal depth is unknown. In 10 feet wide concrete rectangular channel, we have rectangular channel with 10 feet wide. the depth of water is unknown. The Manning coefficient for this channel 0.013, and the slope of this channel is given 0.015, and the discharge, the carrying flow, equal 400 cubic feet per second. This term, cubic feet per second. Wow, how can we do this? Also, Manning equation. Discharge equal K divide N, area RH to power 2/3, S to power 1/2. Let's do it one by one. Q is given 400. K, because we are using US unit, so 1.4868. Divide N 0.013. What is the area of this flow? 10 times depth. I don't know what is the value of depth. That's fine. So 10 times D. What is the value of hydraulic radius? The hydraulic radius value equal area, which is 10 times D, divide weighted perimeter, which is 2D plus 10. Do you agree? Do you have any issue? Depth plus 10 plus depth equal to depth plus 10. So this term will be 10D divide 2D plus 10, all of them to power 2/3. Time, slope 0.015 to power 1/2. Probably if you are smart enough, you can move this number and this number to the other side. So probably on the other side we will have $28.9 equal 10D times 10D divide 2D plus 10, all of them to power 2/3. What is the value of D? This equation has only one unknown, which is the water depth. Anybody can tell me, how can I solve this equation? Probably I solved one like this last week. I remember. Anybody can tell me how can I solve this kind of equation? How? Do you remember the method? Guess. Trial and error. Yes, you have to guess. Thank you. Trial and error. So I will try and see what's going on. Okay, let me solve it here. Let's try depth equal 1 feet. Okay, go ahead and put D equal 1. So 10 times 1 divide 12 to power 2/3 times 10. This value will give you 8.86. I think no, we need 28.9. So I will go above 2 feet and see what's going on. If we have 2 feet, so we have 20 divide 14 to power 2/3 times 20. We have 41.88. No, I need 28. So we have something in between. Let's try. Depth equal 1.5. So 15 divide 13 to power 2/3 times 15. We have 31.41. Wow. So if you go up a little bit, let's try depth equal 1.6 feet and see what do you have. 16 divide 13.2 to to power 2/3 times 16. No, wait. Probably I have a mistake. 16 divide I have 18.2. Are you sure about this value? Let me check it one more time. Yeah, so I think between 31 and 18, probably your depth will be 1.52 feet, something like this. So the final answer, in the exam, you don't need to get the exact final answer, but you see, we need a number 28. So I reach it to 31 and 18. So probably it's very close to 1.5. So it will be 1.51, 1.52, something like this. Okay, so your final depth, the normal depth in this channel will be 1.52 feet by using trial and error. By using trial and error. Okay. One more example. Find the quantity. Quantity means discharge. And velocity of flow in 18-inch diameter concrete pipe. We have a pipe. The diameter is 18-inch. The Manning coefficient for this concrete pipe equal 0.015. Flowing half full. That means the water in this pipe is half full. The pipe has a slope equal 1%. So S equal 1% or 0.01. How can I do it? Okay, using Manning equation. Discharge equal K divide N area RH to power 2/3 S to power 1/2. One by one, step by step. Let's start first. What is the value of area? Anybody can tell me what is the value of this half circle? Yeah, I can tell you what is the area of the circle. Pi divide 4 times this diameter. Make sure your diameter in feet. 1.5 square. This is the area of the whole circle. But we are looking for area for flow only. So I will multiply it by 1/2. Guys, remember 18-inch equal 1.5 feet. Okay, so the area of this flow will be pi divide 4 times 1.5 square times 0.5 equal 0.88. What is the weighted perimeter? What is the weighted perimeter? This length. What do you think? The perimeter of the circle by D. If you multiply it by 1/2, I can get the weighted of the perimeter. The weighted perimeter. So pi times D times 1/2 equal 2.3 0.35. That means the hydraulic radius, which is area divided weighted perimeter, equal 0.37. So this charge equal K 1.468 N 0.015, area equal 0.88, hydraulic radius 0.37 to power 2/3, slope 0.01 to power 1/2. I can tell you what is the discharge. Four 0.4 cubic feet per second. If you would like to go back and use velocity equal Manning equation, that's fine. If you are smart enough, Q equal area time V. Right now, the discharge equal 4.4 and the area equal 0.88. Can you figure out the velocity? Yes, I can. The velocity will be 5 feet per second. I am done. Believe me, if you tried to figure out the velocity using this equation, you will get the same answer. Okay? One more example, and the last one for today. Any questions so far, guys? You have any question? We are looking for quantity, discharge, and the velocity V in 18-inch diameter concrete pipe. Wow, this type is a concrete pipe and the diameter is 18-inch. Looks like the same. Manning coefficient equal 0.015, but flowing in full, but not under pressure because it's still open channel. And the slope equal 0.01, 1%. So what do you think? Do you think we have a difference? Yeah, we have a big difference because area equal pi divide 4 times 1.5 square. Perimeter equal pi times d. And the hydraulic radius equal area divide P. I believe the hydraulic radius will be the same. Do you think? $1.76, 4.71, 0.37. That makes sense. Will be the same. If you have the same hydraulic radius, okay, your discharge equal 1.468 divide Manning coefficient time area 1.76 time hydraulic radius to power 2/3 time slope to power 1/2. I can figure out the discharge. The discharge will be, I think, 8.8 cubic feet per second, and then the velocity will be the same probably. Yes, 5 feet per second. So guys, we covered today very important equation, Manning equation. This equation is very important for your FEE exam after graduation if you are planning. This equation help you to figure out what is the velocity, what is the discharge, and also if the discharge is given, this equation can help you to figure out what is the depth. By using trial and error, you can solve this equation to figure out what is the depth. If you have a circle, that's fine. full or half full. What will happen if you have a circle is partially, not full and not half? How can I figure the weighted perimeter? How can I figure the area? Because you right now you don't have half circle or full circle. You have something in between. How can I figure out this situation? We will cover this next meeting on Thursday.